Okay, in this video we're going to do some questions from the textbook to see how these electricity equations work. So let's do question 1. If a current of 5 amps flows for 10 minutes in an electrical conductor, calculate the number of coulombs of charge that pass a given point. Okay, so in this question we're being asked to find the number of coulombs of charge, which is Q, and we need to find, and we've been given the current, which is I, and we've been given a time as well, which is T. So we need to find an equation that uses these three quantities. Let's have a look in the textbook. Okay, here's the summary page in the textbook, and if we scroll down, we pretty quickly find this equation here. For current, I equals Q over T. Current equals the charge over time, and the units of coulombs are the unit of current is coulombs per second. So we need our charge to be in coulombs and we need our time to be in seconds. So let's go set that up. So I equals Q over T, and we've got to make sure our charge is in coulombs, our time is in seconds, and our current will come out in amps. Okay, so in this instance we're given the amps is 0.5, and we're told that equals some amount of charge divided by time, 10 minutes. But we need the minutes to be in seconds. So let's change 10 minutes to seconds. That'd be 600 seconds. 10 times 60 seconds per minute. Okay, now we just got to solve for Q, so times 600 times 600. And that's going to be Q equals 300 coulombs. Alright, for question 2, if 1.2 times 10 to the 4 coulombs of charge flows in a conductor for 1 hour, what is the current? So this is going to be the same sort of question. I equals Q over T. This time we're given the amount of charge. Q is 1.2 times 10 to the 4, and T equals 1 hour, which is 60 times 60 seconds, so 3,600 seconds. And then we just find I. Okay, and when we put that into the calculator, we get 12,000 divided by 3,600, which comes out to 3.3 recurring, and this is amps. Okay, let's look at the next one. So in question 3, we're given a number of electrons this time. Okay, so that's a little bit different. We haven't been given anything in coulombs, we've been given something in electrons, and this number of electrons goes past a certain point per second, every second. What is the current in amperes? Well, current, I, equals the amount of charge going past a point per unit of time. Okay, so we've actually been told there's this amount of charge, a number of electrons you can say that represents an amount of charge every second. So we know that Q is 5 times 10 to the 18, and we know that T equals 1 second. So that's going to give us amps, except for one problem. If we want to get our current, if we want our current to come out in amps, then the charge needs to be in coulombs. Okay, this will still be a current if we work it out, but it won't be in amps, and we want to have amps. So that's actually supposed to be a 1. Alright, let's change this into coulombs. Okay, here we are back at our summary page, and we can see that to find coulombs, we need to know that 1 coulomb equals 6.2 times 10 to the 18 elementary charges. 1 coulomb is 6.2 times 10 to the 18 elementary charges. So 6.2 times 10 to the 18 elementary charges, that would be 1 coulomb. And we've got 5 times 10 to the 18 elementary charges. So we've got this fraction of 1 elementary charge, this amount of 1 elementary charge, so of 1 coulomb. So these two things will cancel out. All we've got to do is do 5 divided by 6.2, and that's how many coulombs we'll have. Okay, so there's 5 divided by 6.2, it's 0.81, 0.81, so 0.81 equals the number of 0.81 coulombs, which is our amount of charge. So now we just need to put that into this equation here, because we were trying to find amps. So we've got 0.81 coulombs divided by 1 second, which means it's just going to be itself. So 0.81 amps. Okay, finally we've got question 4. I'll do that in a red pen so it's a bit easy to distinguish. How long will it take for a total charge of 720 coulombs to pass through a conductor if a steady current of 0.6 amps is flowing? So again, we've got I equals Q over T. This time we're given the amps is 0.6, the current 0.6, the charge is 720, and we want to know T. So to find T, we're just going to isolate T, get it over the other side. 0.6 T equals 720, and then divide both sides by 0.6. So 720 divided by 0.6. 720 divided by 0.6 is 1200. So we must have 1200 seconds passing for this amount of coulombs to go past a certain point in the conductor if we have this many amps. Okay, remembering that amps is a measure of the amount of charges going past a certain point per unit of time. So it's kind of like, if you imagine the circuit's like a river, it's kind of like the speed of the river. And this is kind of like how much water is going past. So how long does it take for this much water to flow past the point if the river's going this fast? It takes this long, 1200 seconds. Okay, in question 5, a student claims that the charge on an ion in a solution is this, 2.4 times 10 to the negative 19 coulombs. Why must the student be incorrect? Okay, so this student's saying that they found a little charge, a tiny little charge that's on an ion of this amount. Well, let's compare that to the charge on, say, a proton or an electron, which is 1.6 times 10 to the negative 19 coulombs. That's a tiny little proton or electron, that's how much charge it's got on it. Well, this student's saying that they've got 2.4 times 10 to the negative 19. Since these are both the same, we can disregard those. 2.4 is about 1.5 times the size of 1.6. Okay, so effectively, if this is one electron, let's say, it could be a proton, it could be an electron, but if that's one electron, this here, then this is 1.5 electrons. Can you have 1.5 electrons? I don't think so. You can't cut electrons in half, you can't cut protons in half. You can break them up into smaller pieces, but that's not the same as chopping them in half and having half the charge. You can't do that. So this is not possible, because any amount of charge has to be a multiple of this number here, 1.6 times 10 to the negative 19. It has to be a number of electrons or a number of protons. It's got to be a multiple of this number. So that's why it's not correct. Question 6. A steady current of 0.5 amps flows in a wire. How many electrons flow past any point in the wire in 1 second? Okay, so this is again involving current and charge over time. It's again involving that equation. This time we're told that the current is 0.5 amps, and we want to know what is the amount of charge, and we've been told it's in 1 second. So straight away, Q is just going to be itself, so it's going to be 0.5 equals Q. Okay, so we know how much charge is there, but they want to know how many electrons. This Q here is measured in coulombs. If we've got time in seconds and amps, currents in amps, then the charge will be in coulombs, but they want to know how many electrons. So how many electrons are in a coulomb? We've got half a coulomb, so we just need to know half of whatever the number of electrons in a coulomb is. Let's go to the textbook, and we'll see that the unit of charge is coulomb, and 1 coulomb has 6.2 times 10 to the 18 elementary charges. 6.2 times 10 to the 18. So 6.2 times 10 to the 18 charges, that's 1 coulomb. and we've got half a coulomb, 0.5 coulombs. So we've just got to divide that by 2, and that'll tell us how many elementary charges there are, or how many electrons, because an electron is an elementary charge. Okay, question 7. Calculate the EMF of a dry cell that supplies 4.5 joules of energy to every 3 coulombs of charge that passes through the cell. Okay, so we need finding EMF. That's like, it's kind of like a voltage. It's kind of the voltage across a battery that powers the battery, the potential difference. Okay, and so it's going to be a voltage. EMF's basically another word for voltage, but it's voltage across a battery. And we've got an amount of energy and an amount of charge. So we need to find an equation that's got V, it's got joules as energy, and charge is Q. Let's find that equation. So there's our current equation. Here's energy, V equals E over Q. So the potential difference, or in other words voltage, is the potential energy per charge, or the amount of energy that's pushing each charge. So let's work that out. V equals E over Q. We've been told that the energy is 4.5 joules. 4.5 joules, and the charge is 3 coulombs. So if we do this sum, we'll get an answer, we'll get a voltage, and the voltage will be in volts, because we should have energy in joules and charge in coulombs. So 4.5 over 3, that's going to be 1.5, so it's going to be 1.5 volts is the EMF of the dry cell. Okay, question 8. Calculate the EMF of a battery that supplies 960 joules of energy to every 80 coulombs of charge that passes through the battery. So again, we've got we're finding an EMF, which is like a voltage, and we've been given an amount of energy, and we've been given an amount of charge. So we should just have to substitute this energy and this charge into the equation, and we'll know the EMF, the voltage, which is another way of saying the amount of energy that's being applied to each unit of charge. How much force or how much push is on each unit of charge. That's what voltage is, potential difference. So 960 joules and 80 coulombs. That looks like a times table almost. So that's going to be 12 times 8, which is going to come out as 12, so it's a 12 volt battery. The EMF, or the voltage pushing the battery, is 12 volts. Alright, question 9. Calculate the EMF of a battery that supplies 1.92 times 10 to the negative 18 joules of energy to every electron that passes. Okay, so this time we've got a voltage again, and so it's going to be E over Q. And we know how much energy there is. There's 1.92 times 10 to the negative 18 joules for every electron. So for every single electron. But to get an answer in voltage, we're going to need Q to be in terms of coulombs. Okay, we need to have charge in terms of coulombs, not in terms of electrons. So what's the coulombs if we've got one electron? If we go back to our textbook summary sheet, the one electron is 1.6 times 10 to the negative 19 coulombs. 1.6 times 10 to the negative 19 coulombs. That's the charge on one electron. So I've just replaced 1e with that amount of charge. 1.92 times 10 to the negative 18 joules on top. And if we put that into the calculator, let's see what we get. Okay, here we've put the equation into the calculator and it's coming out to 12. And straight away I can probably say, well, that's probably going to be the right answer, because voltages, batteries are often have voltages that are multiples of 1.5. So 1.5, 3, 4.5, 6, 12. So it's probably correct, although you should check the answers just to be sure. Okay, question 10. How much energy does a 12 volt car battery supply to every coulomb of charge? So for question 10, again, V equals E over Q, and we've been told that V equals 12 this time, and we need to know E and Q. Okay, now they've told us that we're working out how much energy, so the energy is going to be the thing we don't know. They must have told us the charge. Well, they have told us the charge because they're talking about supplying this 12 volts to every Coulomb. Okay, in other words, each and every Coulomb, or one, if we measure it for 1 Coulomb, then we'll know how much is being supplied to every Coulomb. It'll be the same. So the equation is, that's going to be E on top. So the equation is 12 equals E over 1, which means 12 equals E. So that's how many joules. 12 joules are supplied to every Coulomb of charge. For question 11, how much energy does a 12 volt car battery supply to every electron? So again, V equals E over Q. This time we've got voltage is 12, energy is what we're trying to find, so we know we're not going to have that. And the charge, we've been told, is 1 electron. Each and every electron, how much energy is supplied to each electron? We've got to convert our charge into coulombs. Okay, if we're going to, if this answer is going to make sense, so we've got to change 1 electron into coulombs in order to put it into this equation. And we know from earlier on that 1 electron has a charge of 1.6 times 10 to the negative 19 coulombs. Okay, so to get E on its own, multiply both sides by this. Do the same on this side. 1.6 times 10 to the negative 19. Put that into a calculator. Okay, 1.6 times 10 to the 19 times 12 equals 1.92 times 10 to the 18. 1.92 times 10 to the 18. To the negative 18. So that is an amount of energy. That's an amount of joules. A very small amount, but an amount of joules nonetheless. So that's how much energy each 12 volt car battery is supplying to each and every electron.